The last problem from the 1112 notes is an application where you're given an algebraic model, I mean you're given the function equation. All right, we're going to solve it. Now I am going to do a quadratic case. Since it's a quadratic case, we will be using the graphing calculator to solve it. If you know the algebraic methods, feel free to use the algebraic methods. Again, they have them. If you know the quadratic formula, if you know how to find the vertex and all of the stuff, using the algebraic method, feel free to do that. Again, I am going to be using the graphing calculator to solve this entire problem. Alright, so the first thing I'm going to, so read the problem. A toy rocket is launched from the top of a 50-foot building with an initial velocity of 120 feet per second. The height of the rocket in feet can be modeled by this function. So there's my function, which I am going to graph in a second. Where x is the number in seconds, and again it's in feet. Alright, so a number of seconds after it was launched, right? Time is the independent variable. Height in feet depends on what time after I've launched the rocket it is, right? So time is independent, feet is dependent. And since I'm going to solve this entire thing on the graphing calculator, that is what I'm going to do. I'm going to go pop up my graphing calculator. I have stuff in there, so I'm going to clear that out from our previous one. So in y1, I'm going to go ahead and graph my function. So I'm going to graph the negative 16 x squared plus 100 x plus 50. Alright, now I do know I need to adjust my window because I start at 50. I know I need to go past 50. So I'm going to go to my window and I'm going to kind of guess. Time is always positive, but I want to see my axis, so I might leave that -2 and I might leave that 10. But what I'm going to go change is my y. My y I'm going to change, again, I know I start at 50, so I know I have to go beyond 50. It's going to shoot up fairly fast, right, 120 miles per hour. And so just to be on the safe side, I'm going to go to 250. Alright, and then I might scale by 50, so I don't have a whole bunch of dash marks there. Again, the scaling is just how many every 50 feet will have a dash mark. That's how all the scaling is. And so I'm going to start there. It's kind of my guess. It starts at 50. It shoots up pretty fast at 120 miles per hour. I may still have to go bigger. We'll see. So I'm going to start there and see if I get a good picture. So I'm going to hit graph. Alright, so I actually did a good job of picking. I can now see my parabola. Alright, so there's my picture. I'm going to go graph it down here. So my graph, so when I graph f of x, which again is that negative 16x squared plus 100x plus 50. I only need the standard window because time, the positive part, because this x is my time in seconds. The function is the height in feet. Alright, so positive height always, positive time in seconds. So again, it starts, it shoots up, and then comes back down. And again, that's the part of the parabola I want, right? It shoots. This is where we start, and then it comes back and hits the earth, and that's where we finish. Right, so the first question, part A. Alright, part A is just asking me to find what's the initial height of the rocket. I actually don't even need my graphing calculator for this. Initial height would be at time 0. Right, at x equals 0, 0 is always the initial. So f of 0, well, they actually told me in the problem where it starts, right? Now I plug in 0 into that equation and I do get 50 out, but they actually told me I launched the rocket from a 50-foot building, so it should make sense that the initial height is 50 feet. All right, that's where we start. So that's this moment here. We start at 50 feet. Then it's launched up, maxes out, and then gravity pulls it back down to the earth, right? Well, gravity is what's acting on it. So there's A, 50 feet. All right. B, I believe they just asked me for a whole bunch of different, so what's the height at 2 seconds, 4 seconds, 6? So I'm just going to find f of 2, f of 4, f of 6, and I'm going to use my calculator to do that. I'm going to go to my calculator, and I can find values on my graphing calculator. Where you do it is get in that second trace, where we do calculations on our graph. So you hit second trace, and I want value, so I pick 1. So I hit enter. Okay, now I want the value 2. Alright, so at 2, it's 186 feet. So 186 feet at at 2 seconds. All right, we'll do the same thing for 4. It's at 194. Actually, tell me where 2 was about right here. 4 was about right there. And then 6 means 6 should be way down here. Alright, so type in 6. 74 feet. So it is way down here. 74 feet. So at 2 seconds, it's still moving up. So that's at 2 seconds. But by the time 4 seconds went by, it was higher than 2 seconds, but now it's on its way down. 6 seconds later, it was way on its way down. It was only 74 feet. A little bit higher than what I have it drawn because 50 is there. Alright, and so it was somewhere around there. Alright, so 2 seconds, it was 186 feet. 4 seconds, it was 194 feet. 6 seconds, it was at 74 feet. Alright, next question. When was the rocket at 100 feet? And so part C, so I'm going to go down here and do part C. We want to know when was the rocket at 100 feet? And so I want to know the time when the rocket, which is what the function represents as the height, when the function equals 100. You could solve it by hand. You take your function, set it equal to 100, and solve. I'm going to solve it by using the graphing calculator. So what I'm going to do is I'm going to type y equals 100 in, right? That's what I want to know. Y equals 100. So I'm going to go to my graphing calculator. I'm going to go to y equal. I'm going to leave my 16x squared, 100x plus 50 there. Underneath it in y2, I'm going to type in y equals 100 and enter. And I'm going to graph, and it should graph that line. So there is the line that represents 100 feet above the earth. Alright, so I'm going to go graph that line up here. Alright, that's my y equals 100. And what you'll notice is there are 2 times it hits 100. Once on the way up and once on the way down. And so I want to find both of those moments. Well, I do that by doing the intersect, right? I go back to my graphing calculator. There are 2 moments where it happens. All right, there are 2 times where it reaches, on its way up, it reaches 100 feet, and it's on the way down, it reaches 100. And that should make sense just from the answers I got in the previous case. All right, it goes up to at least 180, 190, and so it's got to go past 100. And then on its way down, it comes back down past 100 again. So on its way up, it goes to 100, passes it. On its way down, it comes to 100 and passes it. And I want to find those 2 times. All right, so there's 2 of them. Remember, we do this second trace intersect. So second trace, pick 5. First curve, second curve, and guess. So again, oops, I was closer to the other one. Go over to the one I was closer to. Come on, a little faster. I got impatient, now it went past it. Of course. Alright, first curve, second curve, guess. Alright, since we've done it before and I calculated a little bit going out of whack, I do have my answers that I found previously. Alright, so they were found at, if you go and you do that, this one was found at 5.0, not 5.0, it's 5.702. So about 5.7 seconds. And then the other one was at a little over a half a second, 0.548. So again, do the same thing. You go to your calculator, you hit second trace, first curve, second curve, guess. So you get to that moment, you hit the button 3 times, first curve, second curve, guess. And it should give you those 2 answers out. So the answers are at approximately 0.55, around 2 decimal places, and 0.5702, so 57. Alright, so it's at 100 feet at 0.55 seconds. And that's on its way up. And again at 5.7 seconds on its way down. Alright, so twice. Twice it hits 100 feet. When does the rocket hit the ground? Alright, so the rocket shoots up. Alright, shoots up. We start on a building, so it starts at 50 feet above the ground. It shoots up, reaches a maximum, which is going to be the last question, and then comes back down. And at this moment, is where it's back on the earth, right? It's coming back down at a height of 0. Right? This would be represent the ground, right? This is the ground where my height is 0. And so I want to find this moment, which is actually the 0 of the function. And so that question D is asking you, well, it's going to hit the ground when the height equals 0, so when my function equals 0. And so you could solve it. There's a quadratic formula. You could use your quadratic equation, set your equation equal to 0, and solve using an algebraic method. We're going to solve using the calculator. We're going to find the 0 on the calculator. All right, and so that's what we do. Same place that we were going before. So I'm going to clear out that line. My graph out the line. Alright, so I want to find that moment there where it crosses my x-axis. That's the 0. And so we go to second, trace. Right. The second one down is 0. That's what we want. We want to pick 0. And then the calculator is going to ask you to the left of the 0. So I want to get close to the 0 down there. It's almost right where the 4 is in 194. Alright, so I'm going to try not to go a little crazy this time and get as close as I can. And I went crazy. Alright, so there's my cursor above my axis. So there's to the left. I'm to the left of my 0. Hit enter. And now I'm going to go to the right, so my cursor is going to go below it. And I've got to make sure my y switched to negative, right? Positive above, negative below. Hit enter, and then guess. I'm just going to hit my button 3 times. Alright, so it looks like it hits 0 at 6.715 seconds. So my 0 is at 6.715 seconds. Right, that's when it hits. That's the 0. So it's in flight for almost 7 seconds, just under 7 seconds. 6.715 seconds is when it comes back down and hits the ground. All right, the last question. What's the maximum, right? What's the maximum height of the rocket, and what time does it occur? Well, the maximum would be the vertex, so we want to find this. This is what we want, the vertex, which is my maximum. All right, so that's the last question. Which I actually think that was E and that was F. For some reason they were labeled weird like that. All right, so we want to find the maximum height and the time it hits the maximum height. All right, maximum height, when does it happen? Again, we'll use the graphing calculator. Same place that we did everything else in. Second, trace. So again, we want maximum. So we select 4, and then to the last, you got to go to the left of the maximum, the right of the maximum, and the guess. Make sure I go to the left, but not too far to the left. So make sure you go past it. Hit enter, and then it'll ask you to go to the right. So again, make sure you go past it, not at it. And then guess. Again, the closer you are to the number, the faster it'll be. But these are usually pretty fast. All right, so the maximum height, remember, is the y value. So the maximum height is 206.25. It occurs a little after 3 seconds. So the maximum height is 206.25 feet. And it occurs at 3.125 seconds. All right, that's the answer. All right, there's the maximum height, and that's when it occurs. So that finishes up the first set of notes, which again, this was just an example of quadratics. After this, everything else in Chapter 1 and in Chapter 5 will be lines. These will be the only type of quadratics that you'll have to deal with, is these types that I went over here in 1.1 and 1.2. So if you can find quadratics graphically, you should be in good shape. The rest of the work is all on lines, which students tend to find lines a little easier than quadratics. Although quadratics aren't too bad. We'll wrap that